Hello all, this is M. Sandeep Kumar and I welcome you back to my YouTube channel Math with Sandeep. And in today's video, we are looking at the topic called Sandwich Theorem, which is also called as Squeeze Theorem. So this is the sixth video in the chapter of limits. Do check the previous videos if you are new to the channel. Okay. So when do we use Sandwich Theorem first of all? Before knowing what is Sandwich Theorem, first of all, let us see when do we use Sandwich Theorem. What is it? Generally, sometimes it will be really difficult to find limiting value of a function g of x when x approaches a. Okay, using the known methods, it might be difficult to find limiting value of g of x. But we know that g of x is sandwiched between two other functions, f of x and h of x, which means f of x is less than or equal to g of x and g of x is less than or equal to h of x, where in their common domains. So that domain which is applicable to all three functions. Okay, now the domain in which all three functions exist, that is called common domain. Okay, now and remember the common domain contains x is equal to a. Okay, x is equal to a real number a. So when we know that f of x is less than or equal to g of x less than or equal to h of x, and when it is difficult to find the limiting value of g of x, but it is very easy to find the limiting value of f of x and h of x. In that case, we will use Sandwich Theorem. So to understand this concept detailedly, so let us get into it. Let us see what is Sandwich Theorem, which is also called as Squeeze Theorem. So in Sandwich Theorem, what are we going to do is, let us consider three functions f of x, g of x and h of x, such that f of x is less than or equal to g of x, which is less than or equal to h of x in their common domain. Okay, now which the common domain contains x is equal to a, but understand one thing, this is very important. This inequality is true for their common domain. Okay, now except possibly at x is equal to a. So there is a chance that this inequality is not true exactly at x is equal to a. Okay, now we will talk about it after completing this Sandwich Theorem detailedly. Now look at this figure also. This is the graph of f of x, y is equal to f of x. And above, this is the graph of y is equal to h of x, and between the two graphs of f of x and h of x we have g of x. The graph of g of x looks sandwiched between y is equal to h of x and y is equal to f of x. Correct or not? So that is what this inequality means graphically. Okay, fine. And sometimes it is not so easy to find the limiting value of g of x when x approaches a. But it is very easy to find the limiting value of f of x and also h of x. In those cases, we will use Sandwich Theorem. Okay, now when x approaches a, let us assume that f of x is approaching a number L and h of x is also approaching a number L, which means it is observed that limit x approaches a, f of x is equal to L, and limit x approaches a, h of x also equal to L. This number, which is L. Okay, now so but we don't know limit x approaches a, g of x. Then what we will do? So we will use this inequality. So when I use this inequality, we have f of x less than or equal to g of x less than or equal to h of x, and let me apply limit x approaches a for all these three functions. Then limit x approaches a, f of x less than or equal to limit x approaches a, g of x less than or equal to limit x approaches a, h of x. Next, what, dear students? This is known, this limiting value is known, na? It is L. And this limiting value is also known, na? This is also L. So the limiting value of g of x is sandwiched between two finite numbers L and L. What is the meaning of it? See, I'll say one thing. This answer is sandwiched between L and N. That means what? This answer is greater than or equal to L and also less than or equal to L means what is the only possibility? Of course, then this value is also L. So then this is also L. So therefore we can say that limit x approaches a, g of x is also equal to L. Correct or not? So we can say that limit x approaches a, g of x is also equal to L. But you have to understand one thing. What should we understand here is that this inequality exists only in the common domain of these three functions, except possibly at x is equal to a. What is the meaning of it? Means when x is equal to a, we cannot say that h of a is defined or g of a is defined or f of a is defined. We cannot say anything about it. So exactly when x is equal to a, we don't know what happens to these three functions. These are some limitations. Okay, now so and moreover you cannot say that limit x approaches a f of x is equal to f of a or g of a or h of a. We cannot say that limit x approaches a f of x is equal to f of a or g of a. We cannot even say that limit x approaches a h of x is also equal to g of a. There are some limitations. Okay, now and we cannot even say that f of a is less than or equal to g of a, which is less than or equal to h of a. So exactly when x is equal to a, we cannot say anything about the value of the functions f of x, g of x, h of x exactly at x is equal to a. We don't know. This can be an open hole or it can be a closed hole. So we are not saying anything about the behavior of the function exactly when x is equal to a. Okay, now just remember this. Exactly at x is equal to a, we don't know what's actually happening. Whether this inequality exists or not also we do not know. In the neighborhood of a, we can use this inequality. Okay, now so I hope it's very easy to understand what is sandwich theorem now. So you'll get more clarity when we use some examples. So here is our first question, the application of sandwich theorem. If sin x is less than x, which is less than tan x, particularly when x approaches 0. Okay, now remember that when x approaches 0, this inequality is true. Then prove that limit x approaches 0, sin x by x is equal to 1. One of the important limits that we use directly while solving the problems. Okay, now but using sandwich theorem. See, there are many ways of proving limit x approaches 0, sin x by x is equal to 1. Okay, we can prove it using expansions, we can prove it using L'Hospital's method, we can also prove it using sandwich theorem. There are many ways of proving it, but let us see how to prove it using sandwich theorem. Now let us take this inequality. So it is given that sin x is less than x, which is less than tan x. Okay, now if x is approaching 0 plus, that means what? When x is just more than 0, then we know that sin x is positive. Correct or not? Now what happens if I divide with sin x in all three places? So sin x by sin x will be 1 less than x by sin x less than tan x by sin x. So observe that inequality did not change because you are dividing with sin x, which is a positive number. And what if x approaches 0 minus? Then sin x will be negative because x is in fourth quadrant. When x is just less than 0, we are in fourth quadrant, sin x is negative. Then what happens? You have to change the limit, which means you should write 1 greater than x by sin x greater than tan x by sin x. Either way, you will get the same answer, whether x approaches 0 plus or 0 minus, the final answer will be same. So I am assuming this case when x approaches 0 plus, and I am giving the proof. You can try using this one. You can take case 2 when x approaches 0 minus, that means when sin x is less than 0, by taking this inequality. You can prove it. You can try proving this. Okay, now this case 2, but I will go with this one. Okay, now next 1 less than x by sin x less than tan x is sin x by cos x, and already in denominator we have sin x. So sin x and sin x will get cancelled. We understand that 1 is less than x by sin x is less than 1 by cos x. So x by sin x is sandwiched between 1 and 1 by cos x. So now what are we going to do? We are going to apply limits. Limit x approaches 0 in all three cases. Then what do we get? Limit x approaches 0 1 less than limit x approaches 0 x by sin x less than limit x approaches 0 1 by cos x. So when x approaches 0, the value of 1 is 1 only, less than limit x approaches 0 x by sin x less than, if you substitute x as 0, cos 0 will be 1. 1 divided by 1 is 1. So this value is also 1. So understand that the limiting value of x by sin x is sandwiched between 1 and 1. And if I take reciprocals, what happens, dear students? When I take reciprocals, I am just continuing here. So then limit x approaches 0, sin x by x. Okay, now, and this number's reciprocal will come in the left side. 1 reciprocal is 1. and this number reciprocal will come in the right side. 1 reciprocal is again 1. So therefore the limiting value of sin x by x when x approaches 0 is sandwiched between 1 and 1. What is the meaning of it? It means that limit x approaches 0, sin x by x is also equal to 1. So we have proved that limit x approaches 0, sin x by x is equal to 1 using Sandwich theorem. So other proofs can be seen some other time in some other video. So we'll go with the next example. Second example to use Sandwich theorem. Here is our next question. If the natural logarithm of x, ln of x means natural logarithm, we can also write this as log x with base e. Okay, now so if log x base e is between 0 and root x for all x greater than 1. So for all inputs more than 1, log x base e's value is always between 0 and root x. If you know this inequality, then we are supposed to prove that limit x approaches infinity, ln x, we are supposed to find the value of limit x approaches infinity, ln x divided by x. Let us see how to use this to prove. Okay, now let us see how to use this inequality. So step 1, I want ln x divided by x, correct or not? So here also what I will do is divide with x here, here and here. And observe 0 by x less than ln x by x less than root x by x. I did not change the inequality because you are dividing with x and x is positive. X is more than 1 now. So you are dividing with some positive number. So inequality did not change. If you are dividing with x which is a negative number, you are supposed to change the inequality. Greater than will come. Okay, now all these minute basics are important. Okay, 0 less than ln x by x less than root x by x. What is it, dear students? X means root x into root x now. So root x 1s are and root x will get cancelled. You will get 1 by root x. Now I understood that ln x by x is sandwiched between 0 and 1 by root x. Now let us apply limit x approaches infinity. Limit x approaches infinity 0 less than. Limit x approaches infinity ln x by x less than. Limit x approaches infinity 1 by root x. So when x approaches infinity, the value of 0 is 0. And when x approaches infinity, root x also approaches root infinity. Root infinity is taken as infinity. So 1 divided by infinity is how much? 0. Correct or not? So therefore, limit x approaches infinity, ln by x is sandwiched between 0 and 0, then the only possible value of this limit is how much? 0. So that implies limit x approaches infinity, ln x by x is equal to 0. So this is one way of proving that the answer is 0. You can also prove it by using L'Hospital's method. You can also prove it by using expansions. You can also prove it by taking another concept. We will discuss the same question in the concept of limits at infinity. I'll give you different proof there. Okay, now there are many ways of proving it. Okay, this is proved using Sandwich theorem. Okay, we'll go with next question. Here is our third question. There is a function g whose domain is 1, 2 and its codomain is any real number. Okay, now and this function g satisfies, what is it? This inequality. So g of x is between two functions. This is the inequality which g of x satisfies when x belongs to 1, 2. For all x belongs to 1, 2. In that case, they are asking us to find the limiting value of g of x when x approaches 2 minus. Okay, now so x approaches 2 minus means x is equal to 2 minus h, where h approaches 0. Fine. Now let us come back to this question. Let me apply the same limit here, here and here. Then what do we get? So we have applied the limit x approaches to first function less than limit x approaches 2 minus second function less than limit x approaches 2 minus third function. Here x approaches 2 minus means what, dear students? X is equal to 2 minus h, where h approaches 0. Correct or not? So therefore the function becomes what? Limit h approaches 0 cos of 4 minus 2 into, instead of x we are going to write 2 minus h, close the bracket, minus 33 divided by 2 less than, this is what you are supposed to find, less than, again limit h approaches 0, we are substituting x as 2 minus h, so 2 minus h whole square into modulus of 8 minus, let me write that at the bottom, 8 minus 4 into 2 minus h, close the modulus, divided by 2 minus h minus 2. Now if you simplify this value, you will get what? Limit h approaches 0, cos of 4 minus 4 will get cancelled, minus into minus plus h, minus 33 divided by 2 less than limit x approaches 2 minus g of x less than, and here observe inside the modulus what do we get? 2 minus h whole square into mod of 8 minus 8 will get cancelled, we will get 4h whole divided by minus h. Okay now, next, and let me substitute h value as 0. When I substitute h value of 0, cos 0 is 1. 1 minus 33 is minus 32 divided by 2 is minus 16 less than limit x approaches 2 minus g of x. Okay now, so less than, and if I substitute here also, because limit h approaches 0, right? Before substituting, what are we supposed to do is modulus of 4h. What is modulus of 4h, dear students? Since h is positive, modulus is not needed for 4h. Okay, so h and h will get cancelled. Next, you can substitute h as 0. 2 minus 0 is 2. 2 square is 4. 4 into 4, 16 with minus sign. So, minus 16. So, therefore, the limiting value of g of x is sandwiched between minus 16 and minus 16. Okay, na? So, the limiting value of g of x when x approaches 2 minus, okay, is sandwiched between minus 16 and minus 16. Therefore, what is the answer, dear students? Therefore, limit x approaches 2 minus g of x is equal to minus 16. Similarly, I'll write some questions on the board. You can try it yourself. So you can try this question. It is an application of sandwich theorem. So you can try this and let me know what is the answer in the comment section. Okay. So that's it about sandwich theorem, dear students. Let us see where else we can use sandwich theorem in upcoming topics. So this is M. Sandeep Kumar, and I hope you have understood the concept of sandwich theorem and how to use it while solving the problems. If you understand, do like the video, share it to your friends, and do comment if there is any feedback. We'll see you all in next video. Thank you.